All right. Well, good morning, everyone. How you doing today? What? That's it? I mean, we're talking a pretty amazing piece of technology. I need a little more energy. How are we doing today? All right. That's what I'm talking about. All right. Hopefully, we'll be able to get through this in between the takeoffs from Miramar, but we are close to a great military base. And it's interesting starting today with this. Yesterday, we looked at some of the progress being made in opposed piston engines. One of the big areas of progress has been in a military future combat system engine that would be going into a Bradley fighting vehicle. So it's interesting to have that kind of connection as we take the next step with that engine, which is heavy-duty, over-the-road trucking. So I'm Bill Van Amberg, Executive Vice President from CalSTART. CalSTART's a clean transportation technologies consortium of over about 200 companies worldwide, but mostly in North America. And we're really excited to be involved in this project with a fantastic team of public agencies and private companies who are really pushing the limits of driving forward technology that we not only desperately need, but America can be the leader on and can move not only into the United States, but export to the world, because this is world-class technology. So the project what we're talking about, and we'll have some more details through this, is the CATIE's opposed piston, ultra-high efficiency and ultra-low NOx, heavy-duty Class 8 truck engine. It's a project that took a few years to pull together to get the right project team in place, to get the funding in place. But it would lead to tremendous results, and one of the milestones in that project has been met, and that's one of the reasons why we're gathered here today. Because this engine, with its unique architecture, with an opposed piston design, which we'll walk through technically in a minute, allows for much higher efficiency. As much as 15% higher efficiency than what we expect best-in-class diesel to be by around 2027. Now that's actually exciting in and of itself for a variety of reasons, in fuel repay to the fleet, in carbon reduction, in energy savings. But the other piece that this engine is now allowing, which really sets it apart from anything else, is its ability to be 90% cleaner than the 2010 EPA standards for diesel trucks. Now there's only been natural gas engines so far that have been able to achieve that, but what we're able to announce today through this next phase of the project that we're under is that through all the simulation modeling that's gone on an actual engine of a slightly different class size and working with Southwest Research, is that we've been able to achieve the path to that low NOx, 90% reduction from 2010 standards. That's a phenomenal achievement. So the next step is to build the engine. That's the next phase of this project, to build that engine and then to place it in vehicles. So the project team that we have is CATIE's Power here in San Diego, is the technical expertise behind it. They have a best-in-class, world-class supplier team, many of whom are here today, and we'll bring them up and introduce them in a bit. Peterbilt and PACCAR is the truck and engine team that is actually going to integrate the engine into a Peterbilt Class 8 over-the-road truck. We have Tyson Foods and a couple of folks from Tyson here today, as well as Walmart, who will be running these trucks in actual revenue service in California in some of our most polluted communities in Class 8 line haul operation, but different duty cycles as we start to assess it. And then most importantly, the way this came together, there was a fair amount of private capital, but we were able to match this due to some really innovative thinking and aggressive work from the state of California. So the California Air Resources Board has been a tremendous partner in not only supporting these technologies to move forward, but putting significant dollars into this specific project. Together with them, 3 of the state's major air districts also put in significant dollars. South Coast Air Quality Management District, the San Joaquin Valley Air Pollution Control District, and the Sacramento Metropolitan Air Quality Management District, all of whom face NOx emission problems of significant extent in their own basins. So we're really excited about this technology, that it's moved that next notch forward. There's going to be a number of demonstration opportunities to look around and see the stage that engine is at right now and what they've done in other platforms. But really, to move along and kind of talk about the importance of this, why California is putting its dollars so much into this, I'd like to bring up Jack Kotowski. Jack is the Division Chief of the Mobile Source Emissions Division for the California Air Resources Board, and among other things he oversees, he foresees a lot too. Among what he oversees is the funding division that helped bring the dollars to this project. So Jack?
Thank you. Appreciate the introduction. So I'm going to have to add foresee as well as oversee to my duty statement for my boss, so that'll be nice. I'll say that Bill dictated it. It's good. So I'm pleased to be able to be here today representing the California Air Resources Board and to celebrate this innovative technology and this first real-world demonstration of an opposed piston diesel engine that achieves, as Bill said, the cleanest NOx emission standards in the world, significantly reduces greenhouse gas emissions, and meets the demanding duty cycles of Class 8 trucks. We're pleased to be able to provide $7 of the $16 million for this exciting demonstration project. The funding's coming from California's Climate Investments, a statewide initiative that puts billions of cap-and-trade dollars to work, reducing greenhouse gas emissions, strengthening the economy, and improving public health and the environment, particularly in disadvantaged communities. California has made significant progress in reducing exposure to harmful air pollutants over the past 50 years, but many in our state still breathe unhealthful air, and childhood asthma rates are above the national average. So moving forward, California will need to build on its successful efforts to meet critical air quality and climate goals. We will need to be aggressive. SB 32 sets our greenhouse gas emission reduction targets of 40% below 1990 levels by 2030, and reductions of 80% in NOx will be needed to meet federal ambient air quality standards, especially in the most populated areas of the state, such as the South Coast and the San Joaquin Valley. The transportation sector is the largest contributor of greenhouse gases and smog-forming emissions. So achieving emission reductions from our cars and our trucks is critical, and that's why this project is so important. CARB is funding this project to accelerate the development of cleaner combustion technology in the most demanding type of vehicles. Class 8 trucks haul heavy loads, travel long distances. So zero-emission technologies will take longer to mature for these applications. The opposed piston engine is on the cusp of commercialization, and it has the promise to help both our air quality and our climate goals as we continue to support a diversity of technologies. The ability to support both the climate and the air quality goals is absolutely critical. This project will demonstrate the engine's ability to reduce at least 15% of CO2 emissions, exceeding the standards we have in place for 2027. It also meets CARB's cleanest low NOx standard of 0.02 grams per brake horsepower hour, which is 90% lower than today's mandatory diesel standards, and cleaner than any diesel engine on the road today. This will be the first on-road demonstration in the U.S. of a highly efficient, low NOx diesel engine powertrain vehicle developed by a California manufacturer. We're excited about that. The end-user fleets will operate these trucks in disadvantaged communities in the San Joaquin Valley Air Pollution Control District and the South Coast Air Quality Management District. But this demonstration program is just the start. There are thousands of trucks on the road today. No single technology is available that can deliver the goods while delivering the emission reductions we need. So we look forward to the commercialization of clean combustion technologies like opposed piston engines, as well as zero emission wherever feasible to help meet that challenge. So in wrapping up, I'd like to extend our thanks to the partners that will contribute to make this project a success, including CalSTART, the end user fleets, Tyson and Walmart, Peterbilt, and of course, Acades. Congratulations on a great job.
Thanks, Jack. And Jack will be available for questions when we complete here. And I would just say, I think the vision that the California Air Resources Board has put into place has been remarkable. I think some people think of state agencies as bureaucracies. I think what we're seeing is a real innovation. So I do add foresight to oversight, Jack. Let's get that in your Somebody else with foresight for sure, and leading a tremendous team of people is David Johnson from Acades Power. So we have some amazing engineers that we've gotten the privilege to work with. CalStart is the program manager. We'll also be doing a lot of the in-use performance testing of these vehicles when they're on the road. And day-to-day working with this OEM class group of people who really are organized. They do incredibly good technical work and are bringing forward on several platform sizes right now in parallel this OP technology, opposed piston, is remarkable to me. So I'm really pleased to bring up David Johnson to further describe the opposed piston technology from Acades.
Thank you, Bill, and good morning, everyone. It's a great pleasure to welcome you here to our facility in San Diego, but I also want to recognize our team is a 100-member team located here, headquartered in San Diego, but also with facilities in Michigan, and really operating on a global basis. So I'm absolutely thrilled to have this opportunity to proceed with this program and to demonstrate our technology to better the world, better our environment, and better the economy all at the same time. I want to recognize right from the beginning the leadership that California, that the Air Resources Board, that CalStart have shown over a long period of time to help clean the air that we're breathing right now here in California. It is an absolutely phenomenal difference that these leaders have shown in California over an exceptionally long period of time, with a focus on making life better for all of us here in California first, but recognize that it spreads from there. The companies that we work with around the world to make engines and make engines better, make engines for the world. And so what starts in California spreads dramatically and has a meaningful impact to people in every walk of life in every part of the world. But an important part of doing that is actually demonstrating the technology, not just in our labs here in San Diego, but on the road. And so with CalStart and CARB's leadership on this program, we're able to bring together, and we have brought together, class-leading, amazing partners. The team members at Acades Power is one important ingredient, of course, of which I'm personally so proud of what they do every day to bring this technology to the market. But our partners in industry are even it's just a tremendous team. And we have a lot of them here today. I can't do justice to that team in terms of introducing them, so I hope that we'll have a chance after this event for you all to mingle and get questions answered. But frankly, if I could just have those team members raise your hand and say, hey, we're part of this team, because as you look around here, it's a tremendously fabulous team. So if I could, the team members that are actually delivering this project, if you just raise your hand for me. And it's just a phenomenal team, and I thank you for your contributions to date. So just to go back over what Bill and Jack just went through, basically the combination of technologies that we've bring to the market over development now for 15 years and nearly $200 million invested, realize the potential to dramatically lower the fuel consumption, the greenhouse gas emissions, and the criteria pollutants all at the same time, while taking absolutely nothing away from the use of these engines in the marketplace. So to have the full power, to have the full torque, to have the full reliability that our customers and the world demands for transportation, and to reduce fuel consumption, greenhouse gas, and criteria pollutants at the same time, and to do it in a very economically viable way, is the key ingredient of what Acades Power is delivering to the marketplace. And so we're thrilled to have this opportunity to tell you about our project, to introduce you to the technology, and to tell you what's coming in this demonstration, and then for the world in total. So with that, I'd like to show you a quick video of how our engine behaves in a vehicle. So if you can advance the slide just to, here's a picture of our, okay, here comes the video, thank you. So the engine will go into a Peterbilt trucks, two of them actually, one that Tyson Foods will operate and the other one that Walmart will operate here in California in disadvantaged communities. You can see that our engine sits like a conventional engine in the engine bay. It connects to the transmission. The way our engine breathes is quite different than a conventional engine, and we spend a tremendous amount of time optimizing the airflow, excuse me, the airflow through the engine to reduce the pumping work while achieving the clean combustion that's necessary to realize the benefits of our technology. We've got great after-treatment team. It's a key ingredient of what we do. So we're able to get the after-treatment warm and operating at ideal conditions very, very quickly after starting the engine. And that is a principal feature of our engine that we'll realize to achieve the ultra-low NOx emissions that is 90% below the current mandated standard. You can see in our engine we put 2 pistons in 1 bore. That reduces the heat losses and is principal to achieving the fuel efficiency that only our engine can achieve. We've got 2 injectors per combustion chamber. Again, a principal ingredient that allows us to have the clean and efficient combustion that the world demands today and into the future. Our engine is a 3-cylinder engine, but it's a 6-piston engine. So it's very similar from a piston and injector perspective to the conventional engines that power heavy-duty trucking today. We're realizing also significant reductions in the after-treatment cost with this application. And so we think as a total premise for the marketplace, the fleets will want these vehicles not only for their fuel efficiency, but for their cost effectiveness, both in acquisition and in operation. So a 15% CO2 reduction coupled with a 90% NOx reduction is really an earth-shattering type result that we cannot wait to demonstrate for the marketplace. And really, we couldn't do it without our great partners, and I really want to thank each and every one of them for joining us in this endeavor. It is not a small thing that we're doing, but we couldn't do it without you, and we couldn't do it without CARB, so the teamwork that we brought together is hugely compelling to me personally and to my team collectively, and I thank you for that. And so with that, I'll hand back to Bill. Thank you very much.
Well, with that, that will wrap up the formal part of this, but I would like to, at this point before we break, is open this up for questions. We do have people from the technical team that you can meet with, obviously on your own, but any overall questions that anybody would like to ask at this time? Boy, we went through this yesterday, didn't we? I did yesterday. That was no fair. Yeah, go ahead, Stani. Okay, good question. So timing of the rollout of this technology. David, do you want to take that? I can take a first crack. We definitely, on the timing of the project itself, we will have this, we're building up, the project team's building up the engine now, be integrated into a truck, into the trucks next spring towards summer. They'll be tested on the road before they're then delivered to the fleets towards the end of next year, and then they'll be into test service into early 2020. There's more to that question, though.
Yeah, no, that was a great answer to start with. So this project and the timing is dictated actually by the California legislature as they authorize the fundings, and it is a super aggressive timeline that we're working to meet. And so we'll have these vehicles, as Bill's mentioned, the 2 vehicles, one for Tyson Foods, one for Walmart, on the road at the end of next year and testing through the beginning of 2020. But I think it's really important to go to that next step of the timing question that you asked, Danny, that around commercialization. And what we're seeing at Katie's Power, this is one example of what we're doing with our technology, but behind me is another example that we're showing already, and that's our light-duty application where we already have a vehicle demonstrator right here with you, okay? And so what we're seeing as we work with customers around the world is that commercialization is underway. If you need, you can already buy an Katie's Power engine in the form of the Fairbanks Morris opposed piston engine. Makes 5,000 horsepower, best-in-class fuel efficiency, great for power generation, specialized applications, of course, but this is already in production and for sale, right? Additionally, we have work with the U.S. Army to bring better engines to the military, as Bill mentioned at the outset. And this project is running in the dyno cell behind you, and we'll be bringing it to life in Columbus, Indiana, with our partner Cummins in the next few weeks. And then we'll be demonstrating it in a vehicle next year. So the commercialization of this technology in a broad way, case by case, customer by customer, application by application, is already underway. And we at Katie's Power, through our relationships with our customers, we know who's in the lead, and we know who's a little bit later and lagging. And so we're working with all of our partners to accelerate the process of the transformation to this better engine technology.
So just one thing, David, it might be good to just give another step there. As we move forward with this, particularly in the heavy-duty side, and David's right, this is already now in a demonstrator. The military is in bench testing. That will go into a vehicle in the next couple of years, is it?
Next year.
Next year.
Next year.
This engine will be going into trucks for demos. We hope to move into pilot stage and then into commercial production. And so one of the issues is making sure that we get the right commercialization partners lined up. I think if that all lined up, this engine could be in production in 2021, 22, somewhere like that.
So I would love that. That sounds great.
Just trying to push a little bit.
Yeah, no, I appreciate the push, but let me just say, and I have our teammates from Tyson Foods here, they do not want anything that has any downtime or unreliability, because basically a truck that isn't running has to be replaced by another truck that is running, and so we're not solving any problem by doing that. So fuel efficiency and low emissions is only valuable when it's actually doing the job that it was intended for. So for all of our customers around the world, the reliability and durability of the engine is very, very important. And frankly, sorry, as an engineer, the only way to do that is to do it right, and it takes time. So the process of bringing a new engine like this from I want it to here it is for sale tends to be about 5 years. So we're looking at engines for production for this application in the 2023, 4, 5, 6 timeframe. But listen, the world needs this technology, and we have to have the endurance and patience to do all the things and do it right and bring it to marketplace. And my company and our partners, we're committed to doing that.
John?
Can you give us some examples of some of the fuel economy numbers you're seeing now? Understood that they're preliminary and test and not final product, but
I'd be glad to. So first of all, let me just make sure it's all clear what kind of comparisons we do. At Acades Power, we are super rigorous around making sure that we make appropriate comparisons of like to like. So when we compare, we're making sure that the performance of the product is equal to the comparator, that the emissions of the product is equal to the comparator, and then we try to deliver all the benefits that we can with respect to efficiency and cost. So with that said, the truck that sits behind you is a full 30% better than the best-in-class product that are offered in the marketplace today. So that means for gasoline, 37 miles per gallon. For diesel, 42 miles per gallon. That's a CAFE, unadjusted. This is the number that goes into the calculations that manufacturers like Ford, GM, and Toyota and all others have to meet with respect to CAFE standards. That real-world performance should be on the order also of 30% better than the best products in the marketplace today, again, with either gas or diesel, comparing to the best. Now, of course, we have a lot of products in the marketplace that are not at that level of the best. So if you compare this to those products, the number only goes up from there.
I've been on the heavy-duty engine. Or have you gotten to the point where you got any fuel economy numbers?
So as a general premise, the kind of numbers we report there are on a gram per brake horsepower hour on a cycle basis relative to the metrics for greenhouse gas standards, and that's where we expect to achieve a 15% improvement reduction. So I think the number off the top of my head is 391 grams, okay? And that number is 15% better than the current standard, 10% better than the 2027 standard. Thank you.
You're right back. But does that translate into all MPG numbers?
It does, but it depends, of course, exactly on the application, how much mass you're carrying, and so, typically in the world of commercial trucks, that's not our standard number to advertise, and I don't have a number for you at this juncture.
When you said 15%, you mean 15% better in phase 2?
That's right, 15% better than.
Today's engine will be more than 15%.
Yeah, so this is 15% better than the 2017 standard for greenhouse gas, because I know they're changing over the years, so.
Not the 2027.
15% lower than the 2017, 10% lower than the 2027, with 0.02 grams of NOx, so 90% lower NOx. Other questions?
All right. Well, look, there will be more questions, I know, as you circulate. Please find the members of the supply team and others. And I would just call out Southwest Research is here. They've done tremendous work on actually making sure that we can meet that ultra-low NOx standard with the after-treatment system and the design work they're doing with Acades. So there's just some great technical experts around. And I would just say, particularly with US EPA here, which I'm really pleased with, this is a signal that it can be done. Now the question is getting it done, and whether that needs to be a national standard to ramp up to this level or just other inducements. We've got to get this engine out because our urban regions around the world needs it, not just in the US. So thank you very much, Mingle, and I really appreciate you coming today.